Okay, I'm going to make a few measurements just to show you the frequencies in this function generator work as they should. I have to emphasize that the schematic is not very precise nor very documented. So unfortunately, I'm only going to be able to give you an approximation of the waveforms that I'm supposed to measure according to the schematic. But I think it will give you an idea of the correctness of functioning. Also, what I want to show you is that the voltage, the regulated voltage of the power supply does work as it should. I'm measuring at, as you can see, I'm measuring at the exit of the, or the anode of the cathode, excuse me, of the Zener diode. I'm measuring a voltage of 3.62 volts, where the schematic says I should measure 3.6. That's pretty close, so I would say that's good, that's fine. Now, first I want to measure the base frequency of the master clock, which should be normally around 190 kilohertz. So let me set up the time base, which should be on a 10 microseconds time base. Let's see. There you go, 10 microseconds. And a 1 volt per division sensitivity. Alright, so the schematic says I should get the master clock signal by measuring the signal at the collector of this transistor. And indeed, there you go, I get the master clock signal. It should be about 190 kilohertz. So let me see if I can. This is hard. Okay, hang on. I know how. I'm going to. I'm going to hook it up to the transistor like this, with a little hook. There, the collector of the master clock transistor. That looks okay. Yeah, so there we go. So there you go. This is the signal we're getting. Let's see. I'm going to. I can work with cursors. So I'm going to set the reference cursor at one peak, and then the other cursor to the other peak. So I'm going to measure peak to peak frequency, and it says 198, but let's not forget the scope is really not a very accurate instrument to measure frequencies. So it's measuring about 193 kilohertz. Not bad. It should be really 190 kilohertz, since it's the crystal says 190.06, I think. Yes, 190.06 kilohertz. So 193 kilohertz is not too bad. I mean, the precision of the scope. So that's okay. So then we are going to measure just another signal, just one more, and that's the signal of the vertical sync shaper. And it says I should measure that by setting the scope to 5 milliseconds time base. 5 milliseconds time base, yeah. And five milliseconds time base, and I should measure pin 3 of G5. Pin 3 of G5, which is this integrated circuit. Let me see if I can put more light on it. Yeah. So I should measure on pin 3 of this integrated circuit. Yeah. Now integrated circuits are have like these have 14 pins, and if you look carefully, I don't know if you can see this, but an integrated circuit has a little dimple in one corner where I'm pointing the measuring probe right now. That dimple in the top of the integrated circuit indicates pin 1, and the schematic says I should measure the vertical sync signal at pin 3. So 1, 2, 3. That pin should give me the signal they say I should be able to measure. And indeed, there you have it. This is the vertical sync signal. Now, on the schematic, the vertical sync signal is drawn like a very narrow square wave. But obviously, this is not, with these cheap components, this is probably not very easy to achieve. So it's a narrow pulse, but it's not exactly square. Still, the signal looks very much like what it should be if we look at the schematic. You know, this is how the pulse should look like, yeah, according to the schematic, and this is how we get it if we measure it in real. So you see, it's not quite the same shape, but it's close enough. So there you go. I measured the two key frequencies in this function generator, the IG-28. So the next thing would be to hook it up to a television set and then see whether it does function as it should function or not. But since I don't have yet a working NTSC type TV, it'll have to wait. Still, this is encouraging. I think the function generator works, probably works the way it should work. So I'll show it to you next time when I have an NTSC TV set. Also, the next video I won't be talking about the IG-28, which I refurbished, but about a new acquisition. I won't tell you now what it is, but I think I will make it my very first repair project, and I'm going to make you enjoy watching while I repair it. So that's it for now, guys. I hope you enjoyed testing this IG-28 heat kit together with me, and I'll see you next time. Bye bye.